So today we're going to kind of finish the MongoDB query. So I think this is the query we studied in the last class. So we kind of study how to do the aggregate kind of operations in MongoDB. So MongoDB pretty much the aggregate is defined not as a single operator, but rather a pipeline. So you can have multiple operators cascading together. So that's why when you call Mongo aggregate pipeline, you have this parentheses, then you follow by the brackets. So within the brackets, you can define any number of the pipeline or the operators you want. So in this case, we only have one kind of operator, the group. So group is kind of similar to the group by. So we group the documents, the restaurant documents by the type of food, that attribute. And then for each group, we actually calculate the average rating. So this $average is a function, average function. Then we have to specify on which field or which field that we want to calculate the average. Then we assign the average, the calculated average value to that kind of called the variable called average rating. Okay, so this is what we see in the yesterday. Then if, for example, if it's asking for, like, if we want to have the average rating above 4.5, then that means that the first operator will be the group by. So it's generate groups and calculate group statistics. Then the second operator will be the match. So this match basically just specify the conditions, selection conditions on the attribute values or on the kind of some variable value. So now we have $match, then we have average rating, then colon, then the $GT dollars and 4.5. So that's indicate the average rating greater than 4.5. Okay, so this is kind of how the how this pipeline is structured. So then we can have more pipeline if we need, more operators that we need. So for this question, the 2 operators should be enough. Okay, so that's this how this kind of query looks like. So it's going to only print out the restaurant record with average rating above 4.5. Okay. Then we're going to study a very important operator called unwind. So this unwind operator basically deconstructs an array field from the input document to output a document for each element. So unwind basically used to unwind an array of values. So it will generate one document for each value in the array. So here I gave you one example. Assume that we have only a single document. So it has ID field, item field, and sizes. So sizes is defined as contains an array of values, so SML, okay? So if we perform the unwind on the sizes, like what we do here, so db inventory dot aggregate, then parentheses, brackets, then curly braces, unwind, colon, then $sizes. So then the output, the result, basically we will make one document for each value in the sizes. So we have 3 values in the size field, then it will return 3 documents. So the 3 documents will share all other fields value except the sizes. So it's only has 1 size for each document. Okay, so this is unwind. So unwind provides a very convenient way for us to, for example, if our analysis or query interest focus on an array of documents or an array of values, then after we unwind, we can simply, for example, count, for example, number of the objects in an array or number of the elements in an array. So that's provide a very nice way for doing that. So So let's see the example 9. So in this example, it's asking for each person list the total number of awards won by that person. Okay, so we know that awards in the, let me show you the, let me bring my MongoDB interface here. Okay, so if I do the db.bios.find without provide anything, then pretty. So it will list all documents in the BIOS collection. Okay, so then you can tell that awards is an array, so it contains a list of awards. Okay, so then this question asking for the total number of awards won by each person. So I think one thing we can follow the previous strategy that we first unwind each document on the awards field. For example, for this person, the ID is this document with ID 6. After unwind, it will split into 2 documents. These 2 documents shared all the other fields like the name, birth, country-based, and then it will only differentiate awards field. So awards has only single award for each document after the unwind. So this kind of how the basic idea will be. Okay, so let me see. I probably want to add it in the, I think, in the text editor, so it will be much easier for me to copy paste the code. So then we have, let me see. Let me make this window shorter so we can, so I can monitor the students to see if you're able to view it. Yes, I think you're able to do it. So now let's do the, we have db.bios. So let me increase a little bit. Okay. Then aggregate. So the first thing, so we have to define a pipeline of the operators. So the first operator will be the unwind. So we need to unwind on the field awards. So this is awards, okay? So the field name should be start with the $, so awards, okay? So this, the first operator simply unwinds the documents on the awards field. And then after that, then we can group, for example, group the resulting documents by, for example, by the person's name. So that's why the second operator will be group. Okay. Then the ID, so group ID will be the, will be the name. I think we do not need to have these curly braces, so we just, so it will be the name. Okay, so this means that we will group the output documents from this unwind operator by the name. Okay, so after we group, we need to count the number of awards. So for example, I do the awards count. Okay, then I have to use an aggregate function to count. So that's aggregate function will be the sum. For the count, we just column 1, so that indicate we do the count. Okay, then I just want to make sure I have enough curly braces to end it. So I think I missed one curly braces to close the group. I think that's pretty much what we need. Okay, so let's copy this code and to the Okay. Let me see if you're able to view it. Yes, I think you're able to view it clearly. Then let me run. Okay, now it shows the it shows the group ID. So that will be the name. So that's why the name will be appear in the result. And then a word count 3. Okay. Any questions? Okay, good. So let's go to the next one. Yeah, I think this. Maybe let me first. I think I forgot to. So this is find name of people who won 3 awards. Okay. So I think the previous query we're able to get the awards number. Okay. Then this one want to have one like 3 awards. So how we can do, because we have already calculated number of awards for each person. So this number of awards is saved in that award count, that variable. So then we just simply need to select that variable to make sure that it is greater than is equal to 3. Okay. So that's how the query will be look like. So let me need to find my mouse. Okay. So this is the previous one. Okay, so it's previous one. So we just simply add one pipeline on this one. Okay, so I'm now one operator. So in this pipeline we have 2 operators and one and a group. We just need to simply add another one, another operator. So once we produce the group statistic, then we can do the match. So this match basically will compare, pretty much compare some variable value. So we have match. And then, so this time we need to specify the value for the award count. Okay, so we can have, I think, award count. So I think this award count can be without quotes, or we can have quotes. So in the example, we do not have quotes. So match award count, then equals to 3. Okay. So this is match. Yes. So now we actually, for this aggregate pipeline, we have 3 operator unwind. We first unwind documents, then we group documents by name. Then we also produce statistic word count for each group. Then we're going to select the group that has a word count equals to 3. So in this case, it only shows who has won the 3 awards. It shows nothing. It looks like. So let me. I think there are several. A person got 3. So why it's not showing? I think this can be found in yesterday. So somehow I think maybe the internet is not stable. So let me run again. It's so weird. So if I do the word count, greater than, for example, greater than 1. Let's see if this time is working or not. think so. This is pretty hard for the debugging. So because for this one there is no error information, so I remove that match. Just run this one to see. Yeah, we do have the output. So basically, when we do the goodbye and then we count, then we have results. So then if we define the pipeline, then after the goodbye, we can it did just in this case we have to have a curly braces 3, then curly braces to close. I think this close award is close match. So let's see if this is working. You see, I don't know. The differences is that if you compare with the previous one, I didn't have the double quotes to enclose a word count. So if I enclose, this means that, let me see. So that means that when we define our own variable, maybe it's better to use the double quotes. So double quotes used to define a variable name, and then the double quotes along with $sign used to specify a specific field name in the documents. So that's maybe the lessons we learned. Okay, I think now it's working. So that's kind of how we wrote this query. So let me copy paste here. Yeah. Or can I use different? Okay, so this is kind of how it looks like. So in this case, we actually have two operators in this pipeline: a wind, group, and match. Okay, questions? Another thing that's actually, instead of using a wind, there's a size operator to count and return the total number of items in the array. So in this case, if we use size operator, we do not need to use aggregate pipeline. So we have db.bios find, then awards, the column. I think this is award. But anyway, so I think for the attributes name for the find, it's okay. We can do not enclose the attributes name or field name with double quotes unless we have kind of nested field, dot notation to specify the subfield. Then we have to use so basically for the command window, it does not recognize the line. A command split into the multiple lines. So okay, so let's see. Run this command and see what we have here. Okay, so I think this is the same, right? Yeah, we have 4 people. Okay, John McCarthy and Ollie Johan, I think, Dow, and so on. So we have 4. Okay, that's right. Okay, good. So let's see. Question number 11. So list the total number of contributes of each document in BIOS collection. So we know that for the BIOS, the contributes has an array of values. So some people has only one contribution, but some people may have more. I think let's see. For example, this person has 4. But anyway, the contributes is field. It has an array of values. So then it's asking for the total number of contributes of each document in BIOS. So one thing we can do that we can use kind of the unwind operator to solve this problem. Okay. So we do the same thing. We have to do the db.bios.aggregate. And then the first operator will be the unwind. Then we unwind on the contributes. Okay. So after unwind, then we can do the group by. So we can group the documents. The same thing. We group the documents by ID, by the name. So the group by ID will be the name. Okay. So once we group documents by ID, then we can get the variable, I think, country base count, for example. Okay. Then this we basically need to get the count value. So for the MongoDB, the count will be always $sum1. Okay. So and I just need to make sure I have enough. No, I still need 2 more curly braces. So I think now it should be fine. So let's run this one to see. Okay, so it shows the kind of group name. That's basically the name, group by ID, the name, and then the contributes will be listed values. Okay, so some may contribute only one contribution. I mean, identified one can have one contribution. Some have more. Okay, good. So this is for. So now the question number 12. So in the BIOS collection, list the name of a person who had won more than 3 awards. I think we just did how count number of awards, right? Now we just need to specify who had won more than 3 awards. So let's run this query. So still we have to use the aggregate. So we use BIOS documents to the aggregate. Then the first operator will be the unwind. Okay, then we unwind on the field awards. Okay, so once we finish unwind, then we're going to group those documents by name. So we have the second operator will be group. Okay, so inside the group ID will be the name. Okay, then we need to count. So we can have the like award count. So we need to count the number of the awards by each person. So the operator will be the sum one for the count. Okay. Okay. So then it's asking like has had more than 3 awards. So now we have to do the. Just want to make sure I have. So a lot of times just you miss one. You didn't close the curly braces, then you have trouble. So then next one we're going to do the match. So this is more like a having. So when we do the match, we will match the attributes value. Actually, the variable value will be the word count. Okay, sorry. So it's make it smaller. Let me see if you're able to view it. Yeah, I think it's still able to view it clearly. So maybe we can afford it to be smaller. Yes, I think it's still able to see. So when we do the match, we have to specify the value. So it's more than 3. So it means that it's greater than 3. So we have to use gt then 3. Okay. So this specified greater than 3. Then this is specify the variable whose value is greater than 3. Okay. So now let's run this query. See. Okay, now we have 2 people who satisfy this condition. Okay, so let me copy paste the code here. But anyway, so I think we have the code in the next line. Okay, so these are codes. So yeah, and similarly, for example, for the contributes, the same thing. This one is about the total number of contributes for each person. Then we can also have like contributes greater than 2 or greater than 4 and so on. Okay. I think that's okay. This is a little bit different. It's kind of contributes. I think I tried to kind of summarize the exercise we did, but I think we didn't do any one of them. So the first one lists the name of people who receive an award between 2000 and 2010. So this actually used to compare the year. So we want to make sure the year is kind of less greater than equal to 2000 and less than equal to the 2010. Sorry. Okay, let's see this. So you see when we in awards there is a year, 2003 for example, 2002. So basically we just simply select awards year. So for the first one, I think what we need to do to answer the first question, sorry, we just use we do not need to use the pipeline. We just simply use db find. Okay, so we just need to specify more than one condition. So BIOS.find. Okay, and the first curly braces will be the selection condition. So in this selection condition, we need to do the awards dot year. So that's subfields. Okay, then it should be greater than GTE, for example, GTE greater than or equals to 2000. So this is a one condition. Okay. The second condition will be the awards dot year So now it should be less than or equal to 2010. Okay, so that's, we're going to use the LTE 2010. Okay. So now we have selection condition specified. Then it just want us to list the names. So in this field, we just show the names. So we list all the attributes or all the fields should be included in the result. Name, so ID 0. So I kind of force ID not included in the result. Okay. Then we can do the pretty. I think probably even we do not need to pretty because it's only show the person's name. Okay, so this shows the person who has received an award between 2000 and 2010. Okay. Let me copy paste here. I think the remaining two we have already discussed. Okay, so so this kind of in-class exercise, I think we can go over probably 1 or 2. So the first one, in restaurant, list the name and address of restaurants that have a rating higher. So a rating higher than 4.5. So let's say what does restaurant have. So db.find on restaurant. So for each restaurant record, it has URL, ID, address, name, some kind of postcode, rating, and so for this one, I think we even don't have any. We don't need the aggregate operator. Where's my, yeah? It's simply just asking for the rating higher than the 4.5. So we're going to do the db.bios. Oh, no, not bios, sorry. Restaurant dot find. Okay. So inside, we just need to specify the rating higher than the 4.5, then list the name and address. So that's kind of rating. Let me see the right. Yeah, it's called rating. Rating. And higher than, so it's going to have define the greater than equals to DTE 4.5. Okay, so this is a selection condition. Then we just need to have the projections. So projection will be the name. So name, we want to list an address. So we also have address, sorry, listed. Then I don't want the ID listed, so I'm going to put ID 0. Okay. So this is how we answer the question number 1. So we have more. Okay. So I just copy these codes. Okay, it shows. I think it shows a lot more restaurant has high ratings. So those kind of the name and address of restaurants. Okay. So then the second question. Let me probably copy paste the codes here. force them to be small. Okay. Then, so the second one is also pretty simple. In the BIOS collection, for the people who contribute in Java, list their name and awards. So I think this has nothing to do with aggregate. So it's simply just asking us to find the people. So db BIOS dot find parentheses and curly braces. So the first one will be the contributes in Java. So we're going to have the selection on the contributes. Sorry, it will be the Java. So Java is a charge, we have to use code. Okay, and then for those people who have a contribution in Java, we want to list their name and award. So then in the projection list, we have the name and award, and then we turn off the ID. Okay, so this query will find documents who has contribution in Java, so whose contribution contains Java, and we list their name, awards, and ignore the ID. Okay, so let's run this one. Okay, so it looks like a little bit busy, so we do pretty to find out where are they. I think there's only one person satisfied having a contribution in Java, and then he wins like 2 awards. Okay, so let me see. So this is in the restaurant list, the number of restaurants by each postcode. So basically, we're going to go by. So let's answer. So I think this one, we can work on that. So it's asking the restaurant list the number of restaurants by each postcode. So basically, we have to, for example, we have to aggregate the documents, the restaurant documents by the postcode. Okay, so the first operator will be the, I think we only need to use operator group. Then the ID will be, the group ID will be the postcode. I think, do we have postcode? Yeah, we don't go by the ID, will be the postcode. So once we group by the postcode, then we can count. So like the count, for example. Let me use double quotes to make it more elegant. Count. Then we have to use the aggregation operator sum1. That's for the count. And then I have to, I miss one curly braces. Now it's ended. So let's see. So when we use group by, basically if you output only the group ID and the count. Okay. Uh-oh, missing. Yeah, let me see. Group 1, 2, 3. So restaurant, I just want to make sure I have enclose. Okay, sorry. I missed one curly braces in front of group. So now it should be working. Okay, then it shows a lot more. So it shows the number of restaurant. I think majority of them only has one. Some of them has two. Only one has three. Okay. Okay, so I think we only have last one. So list the number of contributes by each person. I think we did that already. So we can either force unwind on the contributes and then group the documents, unwind the documents by name, and then do the count. Okay, so I think that's pretty much for the MongoDB. So there's some other like insertion, delete a document, update a document. I think that's pretty common and also similar to the SQL programming. And then to build the index. So build index is very important because it really can speed up your query processing time. But you just need to kind of find which field or which set of fields are frequently queried so that you can build index on the frequently queried fields. Means that the query has condition. A lot of queries have conditions on those fields. Then you can build index on the fields. Okay, so Mongo has a very powerful index mechanism. So you can build index on the single field or collection fields, and also you can build index on the text field, and even you can build, in fact, index on the geolocation. So there are a lot of nice things about Mongo indexing. I think that's pretty much for the MongoDB. I think for the MongoDB, if you, I think the more you practice with it, it's pretty simpler. So especially this aggregate pipeline is very powerful. So you can have a cascading of the operators. So you can accomplish a very complicated kind of a query. So involved the data preprocessing, involved kind of selection, involved the grouping, and involved kind of projection. You can have selection in multiple locations. So that's very, very powerful. So I think it's powerful in the sense that you can generate some kind of data during the pipeline, like the count, for example. And then you can further process data based on the generated field value. So I think it's more flexible than SQL programming. SQL programming is still, for me, I think it's too stiff. So you have to strictly follow its grammar and structure in order to make your SQL query run. And for the MongoDB, this aggregate pipeline is so powerful. So it can be utilized to perform a lot of complex data profiling, pre-processing, manipulation, and then you get what you need in the result. Okay, so I think I want to stop here. So this is the last lecture for this class. I think I so enjoyed teaching this class, and also I think you all did a very good job in the assignment and also in the term exam. So I think by the end of this semester, there's only one thing you be sure to turn in. That's your SQL project. Okay. So if you have questions regarding the project and if you need help, you just write me email. So we can arrange the face-to-face meeting or the online meeting. So depending on your preferences, but you have to do it by this week. Because next week I think I'm pretty busy for the finals. And anyway, so I'm still able to find a time if you need. So that's pretty much for this class. Thank you so much. So if you receive my email regarding to the summer class, if you're interested in, or if you have any questions, concerns in the summer class, please let me know. I think in the summer class, I'm pretty much will focus on using the sklearn package for the machine learning to practice with different machine learning methods using the real world data. And also, if the time allows, we're also going to study the deep learning models. So if you're interested in, I strongly encourage you to take this class in the summer if time permits. Okay. Okay, good. So any questions from online student? So if you don't have any questions, and if you have any questions regarding to the summer class, just let me know. So yeah, but if you're interested in pursue the data science in your career, in the future career, but I think data science, basically, my personal view is that in the future, it's more like the Microsoft Excel and Microsoft Word. So pretty much all the people dealing with data, I think probably have to have some skill for data analysis, data profiling, data pre-processing, data manipulation, and also build a model to learn from the data. So that's why I have strong confidence in the data science field. And also I think if time permits, and if you are pretty good in Python programming, or confident in Python programming, database programming, I think then we can mainly focus on the machine learning and the deep learning models and how we can apply those models in the real world applications. Okay, so that's just for you to know for this class. So if you have any questions, and just let me know. If you don't, then I hope you have good luck with your finals. And also, if I don't see you, then I hope you have a wonderful summer break. Thank you.